Hello, everyone. Here we have problem 1.45 in the Fundamentals of Mass and Heat Transfer textbook. In this problem, it talks about how a convection oven operates on the principle of creating a higher convection coefficient to more efficiently and quickly bake something. In this problem, it says how the free convection coefficient is equal to 3 watts per meter squared Kelvin. The oven is operating at a temperature of 180 degrees Celsius. And so we're asked when a cake is put into the oven at initial temperature, Ti is equal to 24 degrees Celsius. We are asked to find the difference in the heat flux when convection mode is turned on or off. Here, I already mentioned the free convection coefficient, but the forced convection coefficient is equal to 27 watts per meter squared Kelvin. And we are told that there is a value of 0.97 emissivity for the cake batter in the pan. So over here, I've already written up the entire problem and went through it all. Uh, Here's just a brief drawing kind of showing what's going on. I've written down all the values. Ti is 24 degrees Celsius. T infinity is equal to T surrounding, which is equal to 180 degrees Celsius. I also converted them into Kelvin because because we are dealing with radiation. So we need those values in Kelvin. It's just simply adding 273 to any value in Celsius. And I even wrote down the Stephen Boltzmann constant of 5.67 times 10 to the negative 8. So in this problem, we have a few assumptions just so that we're able to figure out what's going on. First of all, because the cake is indeed baking, it is not in steady state. The cake is increasing in temperature over time, so it is in a transient state. We are uh, because the problem never gave any kind of uh, uh, conduction coefficient in this instance, we're just going to be assuming that the conduction is negligible here, kind of like the pan is just floating in the oven. We are also operating under the assumption of radiation is following a small object in a large enclosure, or a SOL, which just means that the equation for heat flux is far simpler than it would be otherwise. Uh, it is a closed system, and while baking is in fact a chemical process, we are not producing any kind of we are not chemically creating any heat at all. So in this problem, we're just simply being asked to look at the initial heat flux once the cake is put into the oven. So we can just safely say we can just easily use the TI for any and all the calculations. Here I wrote down the energy balance in a closed system, uh, and I made it heat flux. So the heat flux, the stable heat flux is equal to the heat flux in minus the heat flux out plus the heat flux gen. Because the cake is at a lower temperature than the surrounding oven, there is no heat leaving the cake. And as I stated previously, we are not generating any kind of heat in the cake. So it's simply that the stable heat flux is going to be equal to this heat flux going into the cake, which is of course going to be equal to the heat flux due to convection and the heat flux due to radiation. You, you can simply add those together. So the total heat flux is going to be equal to H times T surrounding minus T initial for the convection aspect of it, plus the emissivity times the Stephen Boltzmann constant times uh, the the surrounding temperature to the fourth minus the T initial to the fourth. This is why we needed these values in Kelvin, because if they're Celsius, they're going to be really different. So here you can see I added in all the values and I got a heat flux while we are looking at free conduction. So conduction mode is not on, of 2,356.11 watts per meter Kelvin. Now, if we use that exact same equation, but this time instead of using the free convection coefficient, we're using the forced convection coefficient, plug it all into the same equation, with the forced convection coefficient being 27 watts per meter squared Kelvin. We are now looking at a heat flux of 6,100.11 watts per meter Kelvin. So, and with that, we have solved the problem that we were given. Thank you very much, and I hope that this helped.